When World War II ended, an American manufacturer of fighter jets needed to land new business. The factory employed the same stretched aluminium process used for shaping aircraft wings to make aluminium canoes. No fighting machine, the aluminium canoe is designed for a peaceful day on the lake. The aluminium canoe is strong and silent. Its hull is resistant to damage from rocks or any other underwater objects. So this is one invention that is unlikely to sink into oblivion. Aluminium itself is too soft for canoe construction, so materials like magnesium, nickel and silicon have been added to give it the needed strength. The aluminium alloy is unwound onto a work table. Using electric shears, it's cut to length. The metal sheet is lifted onto a mould of part of the canoe hull. The metal is clamped to a hydraulic system. It pulls and stretches the aluminium alloy sheet to the mould, and it conforms to the mould shape. The moulded sheet needs trimming, so it's transferred to a work table and a template is placed over the contoured section. The template is clamped into place. A pattern is etched onto the moulded aluminium using a scribe. The aluminium sheet is then transferred to a jig. And the pattern is cut, following the etched outline. A second part exactly like the first is also shaped and cut. The two symmetrical halves will form the hull of the aluminium canoe. The hull halves are then baked at 200 degrees Celsius for 8 hours. The heat strengthens the aluminium and adds rigidity. The halves come out of the oven and are aligned together. Next, a large clamp is lowered. Once in place, a crank is turned to pull the two parts of the aluminium canoe together. Now tightly clamped, the two parts are welded along the bottom. This joins them with a watertight seam. The two rounded ends are tacked together with hand clamps and welded. The welds at the end are linked to the one on the bottom, and the result is one continuous leak-proof seam from bow to stern. Next, an aluminium keel is positioned along the bottom seam. It's reinforced from the inside with a T-bar. Rivets are driven through the T-bar hull and the keel to secure the assembly. Substantial aluminium guards are installed on the bow and stern, and again secured by rivets. These guards will protect the end welds. The base of the canoe is braced from the inside with 6 aluminium ribs. Welded, riveted, and with a good support structure, this aluminium canoe has really taken shape. The rim of the canoe is fitted with aluminium gunnels. A rubber mallet is used to improve the fit. Then a non-slip paint is rolled onto the inside, so it won't become slick when wet. The paint dries quickly in the warm glow of these incandescent heat lamps. It takes just 30 minutes. Then it's time to see if it'll float. Important, that. They put the canoe in a tank of water. They clamp a bar across the canoe which applies 450 kilograms of pressure, more than the weight of 2 people. They check for leaks, especially around the rivets. Fortunately, there are none. Crossbars and bench seating complete the fabrication process. There's one last bit of business, and that is the company logo. This aluminium canoe is now ready for recreation. 10 hours in the making, but the fun has only just begun. Unless you're the bloke at the back, that is, doing all the work.